Hello everyone, I am Ishan Upadhyay, currently working as Assistant Professor in Vidyalangar Institute of Technology. I welcome all of you on the second day of webinar on energy conservation and management. Energy is the important input for economic development of any country. For developing countries, energy sector is of critical importance in order to meet its ever rising energy demand. Along with economic development, energy sector has huge impact on our natural environment. This is outline of my presentation. It includes international and national energy scenario. It gives you brief idea of primary energy sources available and their shares. It is followed by energy management and energy audit. In the next part, we will see each type of energy audit in detail with its stepwise procedure. I have also included specimen of final energy audit report for better understanding of report preparation. At the end, a small and simple quiz is arranged for all of you, and for that link will be provided at the end of the session. Before starting energy scenario, energy conservation and management, let us have a quick revision of classification of energy source. Energy can be broadly classified as primary energy and secondary energy. Primary energy is the form of energy extracted from natural resources. This can be further classified as renewable energy and non-renewable energy. Renewable energy is the energy obtained from natural sources which are inexhaustible. Example: wind, solar, geothermal, tidal, etc. These energy resources are replenished and it can sustain against our consumption rate. Whereas on other hand, non-renewable energy is the energy obtained from natural sources which cannot be replenished, or in other words, it cannot sustain against our consumption rate. Example: crude oil, natural gas, coal, etc. Primary energy can be used directly, or it can be converted into more convenient energy form, that is steam or electricity, which is called as secondary energy. Now there are two major classification of energy, out of which ones we have seen just now, that is renewable, non-renewable. Here we have classified energy based on available source. The other way of classifying energy is conventional and non-conventional energy. Conventional energy is a well-developed source of energy and common over long years by usage. Non-conventional energy is comparatively newer source of energy which is still under research and development stage. Let us classify energy sources in given quadrant. First quadrant represent conventional and renewable energy source, that is energy sources that are used over long years, it is well developed, and renewable, that is energy sources that are renewable, that can be replenished. In second quadrant we'll see renewable and non-conventional energy source, that is energy source that can be replenished and that are still under R&D form. In third quadrant we'll see non-conventional and non-renewable, and in fourth quadrant we will see non-renewable and conventional energy source. Now let us place each energy source in the quadrant. Coal is a conventional source of energy. It is well developed source of energy, but it cannot be replenished, so it is non-renewable energy source. Same with the crude oil. conventional but non-renewable. Next is firewood. Now firewood is conventional source of energy. We know we are using firewood from many years, but till forests are there, we'll consider it in a renewable energy source. Cattle dung, vegetable waste, this all will fall under conventional but renewable energy source. Next is oil shale. Oil shale generally refers to any sedimentary rock that contain solid bituminous material that are released as petroleum like liquid when the rock is heated in the chemical process of pyrolysis. So this is non-conventional, it is still under research, but non-renewable energy source. Next is nuclear energy. So still debate is going on between whether to consider nuclear energy under renewable or non-renewable, but then amount of energy we are getting from very small mass of radioactive material can allow us to consider it as a renewable energy source. Next is hydropower, again renewable and conventional energy source. Oil sand. So oil sand is a combination of clay, sand, water and bitumen, a heavy black viscous oil from which refined oil can be extracted. And last is a natural gas, which is again non-renewable and conventional energy source. Once we know energy classification, now we can jump to energy scenario. First we will start with international energy scenario, and first resource we will consider is coal. Coal is a most abundant source of energy. It exists in form of pit, lignite, bituminous, anthracite. In first table we can see countries with maximum coal reserve, whereas in second table on right hand side you can see countries with maximum coal production rate. The largest coal resource is available in USA, that is almost 1/4 of total proven coal reserve, nearly 25%, followed by Russia, China, Australia and India. We will discuss this in more detail at national energy scenario. There is enough coal to last around 113 years at current R2P ratio, that is reserve to production ratio. Now let us understand what is reserve to production ratio. We'll go with one example. If XYZ person have 100 rupees in his pocket and he is spending 10 rupees per day, then for how long his 100 rupees will last? So answer is 100 rupees, that is reserve, divided by 10 rupees, that is extraction rate. 100 upon 10 will give you 10 days. Same way, but on larger scale, we can define reserve to production ratio as, if the reserve remaining at the end of the year are divided by the production in that year, the result is a length of time the remaining reserves would last if the production were to continue at that level. So that gives you idea of for how many years this reserve will last. Due to poor environmental effect, countries are now shifting their consumption from coal to renewable. One important observation that can be made from given table is that China uses as much coal as rest of the world. So here you can see that China producing and then consuming 47.4% of total coal produced by world. Next is oil. Oil is a premier energy source with a wide range of applications. The global proven crude oil reserve was estimated to be 1,687.9 billion barrels. Almost 48% proven oil reserve are in Middle East. At the current rate of production and consumption of US, Russia and China, their oil field will deplete within a decade. With the current rate of production and R2P ratio, oil to last around just 47 years. Here we can see that Saudi Arabia is producing maximum share of oil in the world, followed by Russia, US, China and Canada. Natural gas is gaseous fossil fuel mainly consisting of methane and also include small quantities of ethane, propane, butane, pentane. Before commercializing natural gas, almost all constituent except methane is removed from it. The global proven gas reserve was estimated to be 186 trillion cubic meters. With the current reserve to production ratio, there is enough natural gas to last around just 55 years. In the table we can see that Iran have maximum proven gas reserve, followed by Russia, Qatar and Turkmenistan. Here we have talked about energy resources. Now let us see global energy consumption. Primary energy source is converted into secondary or tertiary energy. Final energy consumption is measured in million tons of oil equivalents, that is MTOE. The global energy consumption in 2014 was nearly 12,730.4 MTOE. In this, share of oil was largest at 33%, followed by coal 30% and natural gas 24%. It may be observed that India's absolute primary energy consumption is just 4.7%, because we are on the second rank for population and our absolute energy consumption is just 4.7%. That gives you the idea of energy crisis in India. If we go sector wise, then industries are consuming 50%, followed by transportation 20%, residential 18% and commercial 12%. Next we'll go for national energy scenario. We'll start with national energy reserve. First is a coal. India has huge coal reserve of about 60.6 billion tons, out of which 56.1 billion tons anthracite and bituminous and 4.5 billion tons subbituminous and lignite. At the current reserve to production ratio, it may last for more than 100 years. Majority of coal, almost 80%, is mined with open cast mining or surface mining. Remaining 20% of coal is mined from underground mines. India have huge coal reserve, still we have to import coal from other countries due to following reason. First reason is our coal production rate is not sufficient to meet our demand. Second is what coal available in our country is of low average calorific value with high ash content. Apart from this, one major issue to import coal is some political issues and some other issues as well. As discussed earlier, the current rate of production is not sufficient enough to meet present demand of country. Hence, we have to import coal from other countries like Australia, Indonesia, South Africa, which requires sea route, and hence it is very much time consuming. Next we'll go for oil. India's estimated oil reserve is 800 million tons. India's crude oil production was about 42 million metric ton against consumption of 175.2 million metric tons. So we are consuming 175.2 million tons against production of 42 million tons. That shows that almost 75% of crude oil we are importing. At current reserve to production ratio, oil in India can last around just 17.5 years. Next is natural gas. Due to the less harmfulness of environment, greater efficiency, cost effectiveness, natural gas is considered as a fuel of 21st century. Apart from this, natural gas has advantage of its high compressibility at lower temperature. India's gas reserve is estimated as 1.4 trillion cubic meters against the consumption of 51.4 billion cubic meters. We are producing 33.7 billion cubic meters, remaining we are importing. India's gas reserve are estimated to last just for 40.2 years at the current reserve to production ratio. So finally we are converting this primary source of energy into the secondary source of energy, and most convenient source of energy is electrical energy supply. So what electrical energy supply available in India? Out of that, you can see that 58.94% share is from coal, then 16.84% from hydropower, that is very big hydropower, then renewable energy 12.34, followed by gas, nuclear and oil. If we find this renewable energy sources and we'll go for each renewable source, and if we distribute this 12.34 among the large hydro, small hydro, solar and wind, then you will find that large hydro is almost 53%. Now large hydro have some of the disadvantages, and because of that large hydro we can reduce by increasing the shares of wind and solar. Wind is a more unpredictable source of energy than solar. Then we can focus on solar, and then improvement can be done to increase efficiency of solar thermal or photovoltaics, so that share of this solar can increase from 17 to some large value, and ultimately that result in increase in the renewable energy source shares as well. This is energy consumption in India. Industry are consuming 44%, followed by transport 17%, residential 14%, and then finally agriculture just 7%. So let's see what is energy management. Energy management is the strategy of adjusting and optimizing energy using systems and procedures so as to reduce energy requirements per unit of output while holding constant or reducing total cost of producing the output from this system. So here we can see energy management is a strategic approach where we can adjust and optimize energy supply with aim to reduce energy input, so that reducing cost of energy. Energy management can also be broadly defined as a proactive, organized and systematic management of energy used in a building or organization to satisfy both environmental and economic requirement. The objectives of energy management first is to achieve and maintain optimum energy connection and utilization throughout the organization. When we are going for optimum energy connection, definitely there will be maximum utilization of energy throughout the plant or organization. Second, to minimize energy cost without affecting production and quality. By minimizing energy consumption, cost of energy can also be reduced. And third, to minimize the environmental effect. This we can achieve by two different ways. First is utilization of renewable energy, and second, utilization of energy with maximum possible efficiency that reduces environmental effect. Next, we will go for energy audit. As per Indian Conservation Act 2001, energy audit means the verification, monitoring, and analysis of use of energy, including submission of technical report containing recommendation for improving energy efficiency with cost benefit analysis and an action plan to reduce energy consumption. In energy audit, we must first monitor, verify, and then analyze consumption of energy. Moreover, we have to find energy saving opportunities and give recommendation to improve energy efficiency along with cost benefit analysis. Finally, all these things are put on paper and a report is made which is to be submitted to the organization. Why do we need energy audit? In any industry, major operating costs are energy, labor, and material, out of which energy has the highest potential for cost optimization. In industry, we carry out many processes which require energy, and it may be equipped with various facilities which again requires energy. So energy audit helps in understanding consumption of energy in various facilities and processes carried out in an industry so that one can identify the scope of improvement in terms of energy savings. Energy audit provides benchmark for managing energy in an organization. So basically, energy audit is a translation of conservation ideas into realities by providing technically feasible solution with economic consideration. It helps to find out power consumption according to different areas and in various lot of time. Types of energy audit. Energy audit can be classified as detailed audit, preliminary audit, and targeted audit. Let us start with preliminary energy audit. Preliminary energy audit is a quick exercise. It is also known as walkthrough audit or diagnostic audit. It actually uses existing or easily available data. Preliminary energy audit can be completed in 2 to 3 or sometimes 4 days. Here, energy auditor relies on his experience, visual information, and quick diagnosis. In preliminary energy audit, following steps are carried out. Step number 1 is to obtain primary data. This can include obtaining electricity bill of minimum last 1 year. Then obtain production or plant related data. It includes data like for how many hours per day a particular machine is operated. Third is estimate the scope of energy saving. From this available data, energy auditor has to estimate the scope of energy saving. From the various scope, he has to identify most likely and easier energy conservation opportunities. For example, unnecessary lightings, leakage, temperature setting, etc. Step number 5 is to identify immediate energy saving improvements with no cost or low cost. that is prioritize various energy saving ideas. In step number 6, set up baseline for energy consumption and then identify areas for more detailed study or the measurement. Let us take example of preliminary energy audit for heat utility system. Let us take example of given house. This is a case of a summer air conditioning system and hence temperature maintained inside is lower than outside temperature. Since inside temperature is lower, heat from outside will leak into the conditioned space. Amount of heat that is leaked inside the conditioned space, air conditioning system will have to remove that much more amount of heat, and that will ultimately act as a load on air conditioning system. So our task is to reduce this heat leakage inside the room. Let us see various leakages. So first, heat can enter through roof and wall. This loss can be reduced by providing cavity wall and wall insulation. Next can be a glass walls. If heat is entering through the glass wall, which is a transparent medium, it acts as a transparent medium for incoming radiation and it produces greenhouse effect. Solar film can be provided to reduce these losses. And the next is floor loss. By providing a proper insulation, we can reduce floor loss. This is one way. Now suppose organization is going for a new air conditioning system, then he'll have two options available: 3-star air conditioning system with lower initial cost but higher operating cost, and 5-star air conditioning system with higher initial cost but lower operating cost. As per BEE guideline, if EER, that is energy efficiency ratio, lies in the range of 2.9 to 3.09, then that AC is labeled as 3-star AC. If it is 3.3 or higher, then it is labeled as 5-star AC. Now EER, that is energy efficiency ratio, gives you the insight of cooling capacity per unit power consumption. For calculation, I have considered minimum EER for the given range. So for 3-star 2.9 and for 5-star 3.3. And some data is assumed over here, that is 1.5 ton of AC that I have converted into form of watt. With the formula of EER, input watt is calculated, and then by assuming some hours per day for which air conditioning system is running and then divided by 1000 to convert it into kilowatt hours per day, we are getting this much unit of energy is consumed per day, and then multiplying that number by 30 to get value for 1 month, and multiplying it for cost that you are paying for per unit power consumption will give you cost for 3-star AC and 5-star AC. This number can vary by large amount if you are varying operating hours. If your per unit cost is different, then this number can vary by large amount. This is called as a cost analysis, and now we will go for payback analysis, payback period. So definitely for 5-star AC I have paid some extra amount. So 3-star AC, which comes in the range of around 25,000, the same configuration 5-star AC comes in the range of 33,000, so I'm paying 8,000 extra rupees. Then how much time will require to get this 8,000 rupees back? That is called as a payback period. This 8,000 rupees which I have paid extra initially is giving me saving of 210.9 rupees per month. If I divide this to term, then I'll get payback period in month, that is 33.93 months, which if I convert in year, then I'll get almost 3 years. So what extra 8,000 I have paid, I'll get it back nearly in 3 years, and after that I'll start making profit from that investment. Same way I can have approach of electrical equipment. Let us take example of the same house having two light source in a single room. We can measure the light luminance per meter square on working surface by lux meter. A lux meter is used to measure the amount of light distributed over a particular area at a specified distance from the light source. If that number comes out to be greater than the standard luminance, so here you can see a standard luminance level for that range is given. If that number comes out to be greater than this range, then I can say that there is opportunity for energy saving. Next, I'll go for detailed energy audit. As the name suggests, it is a comprehensive audit which is detailed energy project implementation plan for an activity. It includes detailed energy cost saving calculation. Key principle for detailed energy audit is energy balance. Detailed energy audit is carried out in three phases: pre-audit phase, audit phase, and post-audit phase. It actually required around 1 month to complete detailed energy audit. Let us now see a stepwise description of detailed energy audit. First step is plan and organize. Any major activity starts with plan. In this step, an energy audit team is established. All standard instruments that are required for energy audit are organized. At the end of this step, energy audit team will be finalized. It may include the plan for audit with time frame. Next is walkthrough audit. In this step, plant activities are understood so that energy auditor and his team will get familiar with the plant activities, and macro data collection is done. Main objective of this step is to collect macro data on plant energy resource. Third is an informal interview with energy manager or plant manager to get more familiar with the things. Second is introductory meeting. A meeting with all divisional heads and authorities that are concerned with energy management is carried out. The main motto behind this meeting is to build up cooperation and create awareness regarding energy saving and its advantages. At the end of this step, energy audit team understands expectations from management. Step number 3 is primary data collection and setting up baseline for energy consumption. Historic data collection can be taken from concerned department. In case of commercial audit, that is energy audit of commercial building, you probably get this data from account section in form of electricity bills. And baseline energy consumption can be setted. Primary data energy consumption pattern can be understood with this step. In next step, energy utility diagram or energy flow diagram or process flow diagram can be drawn. Under this step, plant service utility diagram can be prepared. Here you can see a typical example of energy flow diagram. It is used to show energy flow and energy transformation graphically and quantity wise. Here we can see that input to the combined heat and power unit is a natural gas, which is then converted into heat and power at the cost of some losses. Here thickness of each flow gives you the amount of energy associated with it. This step also includes preparation of process flow chart for energy audit activity. So it gives idea about transformation of energy, material, etc. in the plant. Step number 4 is to conduct survey and monitor. It mainly includes measurement. In this step, with the help of a portable measuring instruments, measurement is done, data is taken, and operating data can be obtained. Once we get data, next step is to go for detailed test for selected major energy equipments. Under this step, energy guzzling device like boiler, pump, compressor, furnace, etc. are monitored for 24 hours. Once we'll get data, we have to analyze it. So analysis of energy use. In this step, by applying energy balance and mass balance, energy loss or waste of analysis can be done. Next step is identification and development of energy conservation opportunity. In this step, ideas are developed for energy saving opportunity. Ideas are reviewed and a lot of brainstorming is done to finalize efficient technology or component that needed for that energy conservation opportunity. Sometime even contact can be made to vendor for new and efficient technology for its pricing and costing. Once we'll get cost, we can go for a cost benefit analysis. In cost benefit analysis, technical feasibility and economic viability is checked for each energy conservation opportunity, and based on that various options are prioritized. Most promising project from this can be selected, and let's see based on what we can select most promising project. It is based on two parameters, economic feasibility and technical feasibility. A project is considered as a good project if its economic feasibility is well defined and attractive as well, and if the technically that technology is already available in market, it's existing technology, then it's easy to adopt it, then its technical feasibility is also good. Such type of project are considered as good, then it can be maybe held, and then no. So based on these guidelines, we can select project which is of most promising. Next is reporting and presentation to the top management. Documentation, report preparation is done and presentation is given to the top management. And then last is a post audit phase. In post audit phase, implementation and follow up. In this step, recommendation given by energy auditors are implemented and its periodic review is taken. So that is all about energy audit. Now, to get the better idea about energy audit report, let's have look at one typical report of energy audit where I was part of that audit. Energy audit consists of general description of process or facility, graphical and tabular representation of annual energy consumption, breakdown of energy consumption in plant, recommended energy conservation and its calculation for payback period, and suggestions for each energy conservation. This is energy audit report where I was part of that team. It starts with executive summary. So here you will find one table where there is entire summary of recommendation. For calculation of this each, you can refer to this subsection. First, this four are the energy saving opportunities we found in that building. First is saving by improving power factor to unity. Next is saving through energy efficient ceiling fan. Then saving by replacing the old tube lights with a efficient one, and saving by installation solar PV panel at the terrace of the building. For these four energy conservation measures, we have to calculate estimated annual energy saving, estimated annual cost, estimated annual investment, and then payback period. Here we have used simple payback period method. Next is introduction to the organization can be given, followed by objective of the audit, and then methodology with some assumption if we have made. Next is energy performance. Here we have to analyze electricity consumption from the electricity bill. We can make such table and we can show it graphically as well, that shows you the pattern of energy consumption for that particular organization. Based on that we can form baseline electricity consumption. Next part is breakdown of energy electricity consumption. Here we can individually calculate what is the amount or the share of tube lights in consuming energy, then fan, computer, split AC, and then such way we can show the breakdown of electricity consumption. Then in final step we have to do calculation for identified energy conservation measure. First is savings by power factor to improve it to unity. For that first we have to calculate annual savings, followed by investment, and from savings and investment we can calculate payback period. This same thing has to be followed to all the energy conservation opportunities. Here we have 4 opportunities, so for all these 4 measures we have calculated payback period, and at the end we have to give general suggestion where we can give some suggestion for future. Say here one suggestion is given that current elevators can be replaced by regenerative panel so that energy consumption will be lesser, and when pump are due for replacement one can go for high efficiency pump. Well, this is energy audit report of a small commercial building, but hence it is small, but it can be very big when you are going for energy audit report for any power plant or some big commercial building, then definitely its size will be comparatively larger. Next is targeted energy audit. At last, targeted energy audit. Targeted energy audit is energy audit conducted based on data or detail available. A kind of primary energy audit is performed on specific target project. For example, an organization may target its lighting system or boiling system or steam system or compressed air system in a view of effective energy saving. Target energy audit involves audit of targeted subject only. Final outcome of this recommendation is the recommendation regarding action to be taken. So that is third and last, targeted energy audit. Now we'll go for advantage of energy audit. Energy audit helps in reducing energy cost in the facility or plant for the same production. Reduction in energy cost helps in reducing production cost in a plant or facility. Reduction in production cost improves competitiveness of product in market. Reduction in energy cost results in lower electricity bills. Reduction in energy cost reduces consumption of natural resources. Reduction in consumption of natural resources, again it helps in reducing damage to environment. It reduces damage to the environment. And finally, reduction in consumption of energy reduces dependency on other nations for natural resources. Let us understand importance of energy audit. Energy audit, even though seems to be very complex activity, it is actually very simple method that uses basic principle of energy conservation and mass conservation. With a simple fundamental principle, one can have huge impact on performance of any plant or facility and hence output of any plant and facility. Suppose energy auditor somehow manages to improve 0.1% efficiency. For any power plant it's big number, but somehow it manages to improve 1.1% efficiency. For the power plant having capacity of 500 megawatt, it results in improvement of zero point 0.5 megawatt, that is nothing but 500 kilowatt. So just by improving efficiency of 0.1%, one can get more power of 500 kilowatt. So that's huge number. This shows the beauty of process where an application of simple fundamental principles results in huge improvement. After knowing all this, one must be thinking about considering energy auditor or energy manager as a career. So here's some guidelines for you. Prerequisite to become energy manager or auditor is to have a graduate engineer or equivalent degree with 3 years of experience. For MTech or ME, it's 2 years of experience. If you don't have experience of 3 years or 2 years in energy sector, then too you can apply for exam, and once you will complete experience, you will submit relative documents, then you can get its certificate of energy auditor. Once your application is accepted by BEE, Bureau of Energy Efficiency, you have to pass 3 papers if you want to become energy manager, and you have to pass 4 papers, same 3 paper plus 1 paper which have more mathematical work to become energy auditor. You have to pass 3 or 4 paper, that is based on you are going for energy manager or energy auditor, with minimum 50 percentage of passing within 3 trials, meaning chance of giving those 4 paper 3 times in total, 1 trial per year as a supplementary exam. Once you have passed all 4 papers, BEE sends you certificate of certified energy auditor. To summarize this, energy is critical parameter for economic growth of any country. If you'll find any well-developed country, then it has huge primary reserve, and that helps for economic development of country. Our country is not self-sufficient to meet ever-rising energy demand, that is well known. Lot of potential is available for R&D of renewable energy. If we look at the share of renewable energy, then it's very less, it can be increased. Energy audit is a vital tool to find energy conservation opportunities. These are some references from where I have taken some numbers. This is where energy auditor book, a guidebook for national energy examination for energy manager and energy auditors. I would like to thank management of Vidyalankar Institute of Technology, Vidyalankar Dhyanpit Trust, Wadala Road. I would like to thank Department of First Year Engineering of Vidyalankar Institute of Technology. I'd also like to thank Shree L.R. Tiwari College of Engineering, Mira Road, for giving me this opportunity. Principal Dr. Ram Reddy Sir, Shree L.R. Tiwari College of Engineering. HOD of Mechanical Engineering Department, Professor Dheeraj Singh. Dr. Kashinath Patil, R&D Dean of KJ Somaya College of Engineering, who actually taught me this subject. Professor Mahavir Bhattacharya of Mukesh Patel, Professor Ninad Mahadeshwar of Atharva College, and Professor Ichanshu Jaiswal from Vidyalankar Institute of Technology for introducing me to this seminar. And finally, entire organizing committee of this webinar. Now, this is a link for quiz. It's a small and very simple quiz which I hope all of you will give. This link will also posted on the chat or as a comment section of this video. I hope you have liked this session. Thank you.